problem number 4, there's a really important theorem that we learned, and it's called the impulse momentum theorem. And it says that force times time acting on an object is mv final minus mv initial for the object. Another rule that we learned is called Newton's third law, which I'll write like this. And it says that basically if you have two objects applying a force to each other, the force on 2 due to 1 is the opposite of the force on 1 due to 2. Now, when things collide, they actually collide for the same amount of time. So, collision times for two things are equal. When you think about it, how could they not be? But just memorize that fact. So here we go. Let's go ahead and actually tackle each of these parts of this problem. So we've got two people running into each other in the football field. They got these pounds, they got these weights, they're running into each other. So let's just talk about what's going on. So who felt the greater force of impact? Neither. It's equal by Newton's third law. Then for part B, neither. By Newton's third law, the force on each is the same. Since the time of collision is the same, this means the impulse is the same. That is, F times t for each is equal. But since impulse is the change in momentum, this means that the answer to C is also neither. And I would want you to actually write down this equation. And then let's see. For this last part, let's just kind of finish this up. And you know what? I'm going to shrink this text down just a little bit. There we go. So, just to continue this for part C, part B, and then for D, the smaller player has a bigger change in V because the mass is less, so V is bigger to make the momentum equal, to make the change in momentum the same as for the bigger object. And that's pretty much how we do that particular problem. Okay. Now, I'm not sure what number 5 is supposed to be, so we're just going to kind of ignore that. All right? So we'll move on to problem 6 in the next one.